Okay.
And move it there. So just click on this little square in the upper right hand corner here, the little gray square, and then just move it over. So I can move any of these. I can move the live stream over here, then I can actually move the chat up here. And again, you're going to have to kind of play around with it and get the UI the way you want it. Now, let's go ahead and put this guy back over here where he was, and then put the video back up here. Now, if we go down to the bottom, we're going to see some pretty important stuff. Now, right here where it says live streaming checklist, it basically tells you what you have to do. Okay, so set up your encoding software. Okay, so your encoding software is going to be like OBS or what other software that you may use to live stream the Twitch or wherever you may be live streaming. So if you're using OBS or XSplit or whatever you may be using, you need to set that up. Now, if I go and open up my OBS here, you can see me here. You got my audio recorder there, so don't worry about any of that. I'm going to go ahead and show you guys. Here's my OBS. I got it set up. Now, you need to know where to find your information. So if we go to settings here and then go to stream in OBS, I can set the service to YouTube, and then it'll come up with my stream key right here. I also have a video on how to find your stream key if you don't already know how to do that. But in OBS, now this is the Mac version, and the Windows version is the same basically thing. You just click on stream, and then you select your service, whether it be Hitbox, Twitch, YouTube, whatever, and then select the server, and then get your stream key. Now, once you get your stream key, copy and paste that, and then go back over to YouTube. The server URL will already be provided for you, and then all you have to do is go ahead and paste the stream key under the encoder setup down below. So once you've done that, your encoder is set up. Now, obviously, you got to go into OBS or XSplit and set up your scene like I have here with your webcam and your desktop and whatever your audio may be. You got to do all of that in your streaming software and make sure that's ready to go. So once you've set up your encoding software, you then want to move on to adding the information for your stream. So as you see here, earlier, or a couple days ago, I streamed some Hearthstone, playing some Hearthstone, and I titled it, I'm sorry, Heroes of the Storm. It was Hearthstone, but it then changed to Heroes of the Storm. I put playing Heroes of the Storm, come play and hang out with the guru, okay? So I just titled my stream, and then I went right here and put a little something in the description, like playing this week's new Tavern Brawl with the viewers. And again, I know that's Hearthstone. Don't give me a grief about it. I was changing games in the middle of the stream. Sorry about that. And then I gave them an option to add me on Battle.net so we could play together with the viewers. Then I went down and changed the category to gaming, obviously, and then I added the game name right here. So go ahead and type the game name there. You want people to know kind of what game you're doing. Now, as you're changing stuff here, you'll see this up here. It'll say changes are being saved. It'll change automatically, and it'll say all changes have been saved. Now, this button right here in the upper left-hand corner that says offline, this little circle thing here, that's going to let you know, yep, you are offline. In order to go live, you need to go to OBS or whatever it is and go ahead and start streaming. You can change the stream options right here. You can enable DVR. Now, DVR is obviously pretty simple to understand. It's going to allow you to stream, and then it'll record the video or the VOD, whatever you want to call it, and then after that you can upload it to YouTube. So you can make the archive of the video private when complete, or if you uncheck this, it'll automatically upload to your subscribers for them to watch at a later date as a VOD. So that's under the stream options. Then monetization, you can monetize it with ads. I've already shown you that. And then you can add a card just like you can. You can add an associated website, fan funding. You can do all of that directly on your stream app here within YouTube. Now, last thing I'm going to show you is you can add thumbnails just like you do here. So go to change thumbnail, add you a nice little thumbnail like I did here, and then you obviously have chat. So under chat right here, you have where you can see where people were chatting with me. We were talking about some stuff related to the game, or maybe not related to the game. Either way, chat's right here. You can hit the little gear icon to enable or disable chat. You can decide whether or not you want to have chat or not. I would recommend doing that. And then if you want to say something in chat, you can just type it in here and then press enter, and then it'll obviously chat via text to all of your viewers that are watching. And then once you do start streaming and you do go live, you're going to see something here under analytics. Under analytics, you're going
kind of understanding. When particles scream.
But in some deeper sense, the fact that the universe is mathematical.
By saying that the universe didn't.
It's become indistinguishable from nature itself. As physicists search for answers to fundamental questions about the beginning of the universe and the role God may have played in it, some wondered how this
Stars, but some cosmic detonations are so powerful that they briefly outshine their parent galaxy. Flood.
Somewhere, far from Earth, a star enters its death throes and explodes in a violent supernova, leaving in its wake the strangest phenomenon in the cosmos, a black hole. Our galaxy may be infested with millions of them. But now, there's evidence of something even more ominous. Black holes of unfathomable size and power.
That's a big galaxy, and right down at the center, you can't see it, a black hole that's got a mass that approaches 1 billion suns.
Astronomers are now studying them in unprecedented detail and finding they are bigger, stronger, and more destructive than anyone imagined. We'd like to think black holes are far, far away. But what if there's one on our cosmic doorstep? A team from Europe and another from the United States are in a high-tech race to be the first to see into the very heart of the galaxy. Now, an extraordinary new experiment is giving astronomers a first-ever glimpse inside a black hole to see what's in the lair of the monster of the Milky Way. A new era in astronomy has begun. High-tech instruments in space are now revealing a universe rocked by violent events.
JPL Chandra, see?
In the distant galaxies, astronomers have witnessed space and time shattered by eruptions so vast they boggle the mind.
To put this on sort of an Earth scale, it's equivalent to about 1 trillion atomic explosions.
But what could produce such awesome power? Whatever it is, it lives at the center of our own Milky Way. Scientists now believe it is the largest and most powerful object in the universe, and yet it emits no light. It is called a black hole. First suggested by Albert Einstein's equations, a black hole is space and time twisted into a furious knot. But the great scientist believed it could never exist in nature.
Albert never really liked the idea of black holes himself. He thought they were anathema. This was something that nature should avoid. It's the places where space and time became infinitely twisted up. He thought, no, nature shouldn't allow that.
Black holes are certainly odd beasts in the universe. They were thought to be peculiar, so peculiar as to perhaps not even really exist in the real world. Simply because your equations show that they can exist doesn't require that the real universe has them.
That there is something strange and powerful lurking in the center of our galaxy first became clear 75 years ago. Early radio telescopes recorded a hiss like the sound of steam. As a young astronomer, Eric Becklin was determined to get to the bottom of this mysterious energy source. First, he had to find it.
There was a radio source called Sagittarius A, a very strong radio source, but there was even debate whether that was really the center or not.
Astronomers knew that the centers of other galaxies are tightly packed with stars, but when they tried to see into the center of our galaxy, those stars were obscured behind a thick veil of dust.
There is so much dust between us and the galactic center, it is completely opaque. You do not see the stars in the galactic center. The most powerful telescopes cannot see it.
Becklin knew that some kinds of light, invisible to our eyes, can make it through the dust. Infrared, for example, travels in slightly longer wavelengths.
Infrared radiation gets through the dust because its wavelengths are longer and the dust just kind of rides on the infrared wave.
In the 1960s, Becklin bought an infrared detector from a military contractor and attached it to the end of a telescope.
It was in August of 1966. It was a beautiful night. As we were looking with the infrared detector, we were seeing more and more stars, and the signal increased, and each star gives you more signal, and we were building up, as we were getting closer to the center, more and more stars. We were actually seeing through the dust for the first time, and then came to a peak, and then back down again. And I knew immediately that that was the center of our Milky Way, and that I was the first person to actually see the stars in the very core of our galaxy.
Eric Becklin had discovered the very heart of the Milky Way, the exact location of the mysterious energy source. But its staggering power meant that this was no ordinary star. Scientists believed the only one thing that could explain the mystery was the very idea that Einstein had rejected, an object that defies explanation.
What's a black hole? It's this monstrous, mysterious thing.
It's a point of infinite density. We don't know how to wrap our brains around that.
It's a region where space and time have closed in on itself.
A black hole is a region of space where the pull of gravity is so immense that not even light can escape it.
You reach the point where light cannot even come out. And if light can't come out, you're not coming out. And if light plus you are not coming out, it's a black hole. There's no other phrase we can possibly use to describe it.
Welcome to the strange world of extreme physics, where space and time literally cascade into the abyss.
Space itself is falling inside the black hole. It's rather like a river falling over a waterfall, except it's space itself that's falling over the cliff. It's rather like a kayaker trying to make their way upstream on a river that's going too fast. They get dragged down to the center of the black hole.
Gravity becomes a riptide. The closer you get, the stronger the current. Eventually, you reach the event horizon, the point of no return.
Matter goes inside the surface of the black hole, shrinks down to the very center, where it gets destroyed in a region of infinite warp space and time, and it's gone.
The gravity at your feet, if they're close to the black hole, is a little bit stronger than the gravity at your head, and you feel that as something that is tearing you apart.
The tidal forces unrelentingly getting stronger as they exceed the molecular forces that bind your flesh. And so you end up moving through space-time like toothpaste through a tube.
And ultimately, you will pull your atoms apart. You will be, as we say...
As strange as they are, black holes are a product of the familiar universe of stars and gravity. They have their genesis in a type of enormous star called a red supergiant. It is 10 times heavier than our sun, yet it will burn itself out in a fraction of the sun's lifetime. inside. The crush of gravity sends temperatures roaring above 1 billion degrees. Helium and carbon fuse into heavier elements: oxygen, silicon, sulfur. Then, the star implodes under its own immense gravity, sending a shockwave roaring out. The star digs itself deeper into space travel, and now goes supernova in a violent explosion. What's left is a dense core of subatomic particles, a neutron star, only about 16 kilometers across.
It's so dense that a teaspoonful of neutron star matter would weigh about 1 billion tons. Eventually, the gravitational pressure will be so large that the neutrons themselves will be crushed, and there'll be nothing left to stop the collapse.
A black hole is born. It's 1 million times the mass of the Earth, but compressed so tightly, it literally exits the known universe.
Now, the effect of that mass is still in our universe. The mass is still here in that it's causing this fold in space that goes all the way down. It's become a hole. The best way to look at it is, if you stick your finger down in there, you ain't getting it back.
We know exactly what effect a black hole is going to have on its environment, on the stars in its vicinity, on the gas that wanders a little too close. So, will we ever see a black hole? No. But that's not what's important here. What's important here is we can see its paw print.
In search of a black hole's paw print, Eric Becklin is on a lifelong quest to probe the center of our galaxy. The Milky Way is a giant spiraling disk of over 100 billion stars. Our sun is